Hello, let's look at number 5. It says a light, rigid rod. So light means I can ignore the mass of the rod, okay? Attached to its ends is pivoted about a horizontal axis shown above. When released from rest in a horizontal orientation, the rod begins to rotate with an angular acceleration of magnitude what? So I'm looking for alpha, right? So this is actually very similar to something like F net equals ma, okay? But I have to do it in a torque version, okay? So for torque, I have something like torque net equals my sum of my torques, okay? So I have a torque from this, and I have a torque from this, okay? So let's do the green side first. So it's going to be RF, or L, 3m naught G, okay? So that's my R, this is my F. And then the blue side is going to be subtracted because they're doing opposite angles, okay? And that will be 2L m naught G, okay? So I have that, but then I also need to do my torque net, which is just I alpha, okay? But I actually haven't found alpha I yet, my moment of inertia. So I need to go ahead and figure out what that is, okay? Remember, it's going to be the sum of my mr squared, okay? And so the green one is just going to be 3m naught L squared, plus my blue one is going to be m naught 2L squared, okay? And so then that's going to equal, I have a 3 here, m naught L squared, and then plus, this is going to be a 4m naught L squared, okay? And so that will just equal 7m naught L squared, okay? So that's my I, so I'll have 7m naught L squared alpha. Remember, that's what I'm solving for. And then I need to subtract these two things. So I have a 3 here, a 2 here, so that would just be m naught LG, okay? So you'll notice our m naughts will cancel. One of our L's will cancel, okay? So I'll have 7L alpha equals G. And so then my alpha will just equal G divided by 7L, okay? And so the correct answer would be A.